People who are eating high protein, low carb are going to have higher protein requirements versus somebody who's eating closer to our mixed meal recommendations. Weight loss is easy. High quality weight loss, you got to be a little more thoughtful. And high quality weight loss is trying to maximize fat mass loss by preserving as much muscle as you can. Our muscles are in a constant state of turnover. So a great analogy is if you look at your arm muscle, within 3 months, you've completely renewed that protein pool. We really want to make sure that we got optimal turnover of that protein pool because we want to get rid of those damaged proteins, make sure we're incorporating less damaged, higher quality proteins.
In today's episode, we are joined by Associate Professor Nicholas Burd to once again talk about protein. In this conversation, we focus on the fate of protein. When we eat protein, how do we digest and absorb it? Where does it end up? Nicholas walks us through the difference between optimal and maximal protein intake and why he thinks people may not need as much protein as they think. Are collagen or amino acid supplements worth taking? And plenty more. Before we get into things, if you haven't already, it would be greatly appreciated if you could follow or subscribe to The Proof on YouTube, Spotify, and/or Apple. This helps the show more than you can imagine. Enjoy the episode. This is Nicholas Burd, PhD. I thought we'd start off with learning a little bit about the research that you're doing. When you meet someone for the first time and they inevitably ask you what you do as a scientist, how do you kind of go about describing your work and career path so far?
Sure, yeah. So I'm an associate professor at the University of Illinois in the Department of Health and Kinesiology. I was trained as a muscle physiologist. So enjoy exercise, enjoy nutrition. Two major stimuli to skeletal muscle. So I think definitionally I'm probably more in line with an exercise physiologist. And so normally that's when people ask, what do you do? I'm an exercise physiologist. In terms of my research, I study nutrition, exercise, and substrate metabolism with a particular interest in skeletal muscle tissue, just because the amount and quality of skeletal muscle we have generally is going to dictate our exercise performance. So it's just a real important target tissue for us, but I certainly am a physiologist, so think more holistically as well.
Yeah, what does a muscle physiologist actually mean to someone who's kind of hearing that for the first time?
Yeah. Great question. My grandma asked me that all the time. I'm a human muscle physiologist, so I study human muscle. I would say a lot of times whenever somebody sees a muscle physiologist walk into the room, they try to run away because that means we're going to be chasing a piece of muscle out of somebody's leg. So, it can mean different things. I study it, like I said, from a metabolism standpoint. So we'll collect small pieces of a tissue from human participants in response to some sort of nutrition and exercise manipulation. And then we probe different readouts depending on our research question. I have a particular expertise in using stable isotope tracers to study protein turnover or protein synthesis and breakdown, but certainly complement that output with other measurements at the molecular level. Also have an interest in glucose metabolism, but I would say my bread and butter probably is protein metabolism. That's what most people would identify me as.
So why is that? Why the interest in protein? If you're a muscle physiologist, you're interested in how muscle functions, how we can improve the function of the muscle. Why is protein so important to that?
Yeah, so I'm particularly interested in looking to see how our muscle proteins are renewing or remodeling. So again, it's real important, whether we're an athlete or an older individual or any disease state, really, that the amount and quality of protein we have is going to generally dictate everything you just said. So function, metabolic health. So we use, like I said, fancy tools to directly look at that remodeling process. And it's important that, our muscles are in a constant state of turnover. So a great analogy is if you look at your arm muscle, within 3 months, you've completely renewed that protein pool. And so we really want to make sure that we got optimal turnover of that protein pool, because we want to get rid of those damaged proteins, make sure we're incorporating, less damage, higher quality proteins.
That's a really interesting thing, I think, for people to kind of wrap their head around. When we talk about aging muscle and the elderly and how skeletal muscle functions as we age, it's not that we've had those muscle cells with us our entire life. Like, those cells have turned over and they're actually, quote unquote, new cells. Would that be accurate?
No, yeah, I mean it's a tricky question, right? So when we're viewing a muscle fiber cell per se, we usually just call them a muscle fiber, as opposed to a muscle cell. I think you'd intrinsically think of muscle fiber. So there's always this debate whether what happens with any type of, whether you're getting a bigger muscle, different quality muscle. In humans, we generally, at least there's no support for it, we think that basically the number of muscle fibers or the number of muscle cells you have at birth are pretty static, but the size changes, right? So what I'm sort of referencing, so you have a cell or a fiber, those proteins within that cell or fiber are changing or being renewed. So animal models are very different. They see something called hyperplasia, and I think it's just based on the different stimuli we place on our muscle. So they usually use chronic overload models. So if I, like, I'm talk to my class sometimes, I'm like, well, if I take a human, not that we'd ever do this, and hang them up by their legs so they're chronically loaded for days and days and days, we could probably see that cell number change. But we train, we move submaximally. We're, even when people go to the gym, they're not hitting maximal efforts. Usually it's some percentage of a max efforts, and it's usually for 30 minutes to an hour. So it's not that we don't have the programming probably to get new muscle cells. It's just that how we function, it doesn't translate. That information doesn't actually get translated into actual new cells. So the cell number is the same, but the protein within those cells can change, I guess, and can be different based on an athlete versus obese person versus an older adult. And then we're even seeing that older adults are probably getting differential regulation, whether you're female or male. We just published some recent work showing that female older adults are responding a little different to feeding and exercise stimuli than their aging male counterparts, which is interesting in itself, I guess. So you can split that multiple ways.
Yeah, let's put a pin in that and make sure we come back to that and what that might look like for the listeners. But just to kind of double click on this, hyperplasia. So hyperplasia being an increase in the number of muscle fibers. You're saying the research suggests that probably doesn't happen so much in humans. It might happen in animals. But hypertrophy, which is another word that a lot of people have heard of, is not speaking to an increase in the number of muscle fibers, but just increasing the size of the existing muscle fibers.
That's correct. That's exactly correct. That's what we think happens in humans. Even there's no evidence in even people who are using exogenous steroids, which obviously you manipulate your testosterone levels to be high for a long period of time. They don't even see hyperplasia in those models. Which you might think that might happen in that model, but there's no evidence for that, even in, like I said, at those super physiological levels of exogenous help.
I've heard some people, and they might be kind of speculating here, that it might depend on the stimulus. So within the kind of, I guess, powerlifting, bodybuilding community, there's this idea out there that if you lift at long length, so you put the muscle under, it's in a lengthened position, and then fatigue it. So, take it to that point where you're within a couple reps shy of failure, that might induce hyperplasia. Is that something that you've come across?
No, I mean, we haven't seen it. I mean, the thing with lengthening contractions, right? They put more force on your muscle, so it creates more So damage usually is damage is a tricky word in my field. So you can think of damage in the sense of when you get Z-line streaming or your sarcomeres are sort of get messed up, which is basically what the structure of your skeletal muscle. I view damage in any disruption of homeostasis. Um, so it's always important that you get a definition. But when people are doing these lengthening contractions, you're you're generally getting better cross bridge formation and more force put on the muscle, and that's going to be more damaging. But even those type of contractions aren't going to cause hyperplasia, at least based on the evidence. I mean, I could be proven wrong, but there's no evidence for that notion. A lot of that, Simon, when I view, I'm always, I'm not never here to tell somebody's right or wrong. I mean, whatever somebody if they enjoy going to the gym and creating a lot of damage, and that makes them be consistent, that's the most important variable. You need to go to the gym, be consistent, and that's it. Obviously work hard, and if somebody enjoys doing lengthening contractions, go for it. It is more damaging, but it's not necessary. I mean, the problem is when they try to provide an overarching recommendation and try to say everybody needs to do it this way. That's just not the case. That's not the basis of hypertrophy, is not damaging your muscle via eccentric contractions. You don't need to do that to induce a bigger muscle.
What do you think about? So, I mean, we're kind of, I guess, the take-home point here is that as we increase a muscle size, it's the muscle fibers themselves increasing. We're not increasing the actual number of muscle fibers, which would be hyperplasia. So that's the point that I kind of want to underscore for people. But do you think there's any benefit at all to doing resistance training and taking the muscle to a fully lengthened position if someone's goal is hypertrophy at all?
I mean, whenever you're thinking about any type of training paradigm you're doing, I mean, I always think about I'm thinking about the translation, what's my function, right? I'm normally more interested in power per se, which has a time component to it. But if somebody's encountering something that has a lot of lengthening contractions, which and they need to be very good at that particular angle, then obviously training specificity is going to reign supreme. But there's nothing intrinsically magical about lengthening lengthening your muscle length for hypertrophy. The fundamental basis, at least in our hands, of what we've seen, and I worked with Stuart Phillips up at McMaster University during my PhD. His research group, and when I was there, we did a lot of work trying to understand what's the principal driver of hypertrophy, and we came to the conclusion or thesis that it's all about fiber type recruitment patterns, in particular recruiting those type 2 muscle fibers, which are the more hypertrophic in nature. So, go to the gym, work hard, try to activate as much muscle as you can, and that's going to induce more hypertrophy, right? Not necessarily just focusing on a lengthening contraction. Obviously, most contractions are going to have both. But again, training specificity, if you're training in a particular sport where you need that sort of movement, then, you got to work with the strength and conditioning professionals to make sure you're optimizing your training regimen to perform better at whatever discipline you're trying to do.
I ask this because it has become somewhat of a trend, I think, on social media, this idea of like long length partials, particularly at the end of an exercise. Like if someone's doing, bicep curls, for example, right at the end when they feel fully fatigued, just doing partial contractions at length. But what I'm hearing from you is that might not matter so much.
I mean, I wouldn't say, at least using the tools we have, we'd be able to distinguish the difference. And my thesis or my hypothesis wouldn't be that adding those small contractions at the end of regular contractions are going to be more hypertrophic in nature. But again, if somebody enjoys doing that and that sort of makes them feel like I've completed my exercise set, go for it. I mean, at the end of the day, like I said, making sure you enjoy what you're doing to be consistent, or if that makes you think you're working harder, I'm all about it. Obviously, if you're trying to translate that to sport, you got to be a little more thoughtful because you just want to make sure whatever you're doing is translating to your particular discipline. But if it's purely hypertrophic in nature and you enjoy doing that, then go for it. But I don't understand. I don't think, just as me speculating, I wouldn't hypothesize that would be more hypertrophic than doing a normal set.
We've kind of just jumped straight into the deep end here, but just to kind of preface this conversation, I've covered protein a lot on this show. Some of the listeners are probably thinking, really, how much more do we need to know about this? So it is possible that my curiosity is kind of getting the best of me here, but I do feel like there is still room to learn more. If we kind of take a couple steps backwards here, do you have any views about protein that may be different to some of the other kind of main scientists that are researching protein metabolism, like you mentioned, Stuart Phillips, Don Layman, these folks that I've had on the show? Are there any kind of views of yours that you would say stand out as perhaps different or more nuanced than those guys?
Yeah, I mean, so we're talking about food protein. Now, I guess you're alluding to Simon, so dietary intake. I would say everybody in the field is, we're following the data, we're learning as we're going. Like Stu is my mentor. He's my, I mean, he's done so much for my career. I still learn to this day from Stu. Donnie, I obviously know Don Layman, but I'm less connected to him. He's a professor emeritus here at the University of Illinois, actually. I talked to him a few times over the year. But Stu and I, we have similar beliefs. I believe. I mean, we're just following the data, and our beliefs are probably changing as we learn more. I mean, I'm trying to think what some of Stu's hypotheses are. Again, he's very thoughtful about making sure the information he is providing is translatable. So you often will hear Stu sort of aim at the upper end of the continuum in terms of the amount of protein required to maximize hypertrophy, right? So I think sometimes I see him say 1.6 grams protein per kg per day. And those kind of recommendations, I always view those as more maximal in nature, not really optimal per se. I think a lot of times people confuse those words, optimal versus maximal. So those high intakes are just trying to make it easy for people. Those are maximal intakes. So 1.6 upwards of 2.2 grams per kg per day. That's just an easy, surefire way to maximize protein intake. Now the question is, do you want to maximize or you want to optimize? Because that's a completely different conversation. And I think I often see, I'm not big on social media, but I can see people interchanging those words. They don't mean the same thing. They're very different in terms of how we handle the food protein. But if you're interested in maximizing, yeah, aim high. Just aim high and, you're fine. Or if you're trying to optimize, you got to be a little more thoughtful with your protein nutrition. It's just, it depends on the goal and the individual and who you're talking to. An athlete, you try to make their life easier. So you're going to probably give maximal recommendations just to take some thought out of their daily regimen because they're already heavily loaded down with their training regimen. So it just, like I said, it depends.
So what is the difference there between maximal and optimal? How do you define maximal versus optimal?
Sure. I mean, you could obviously go to Google and define it, but when I think about it from a protein metabolic standpoint, so a maximal intake is your only goal is trying to. Now, again, I do a lot of acute protein synthesis studies, so I should make sure we're clear on what I'm talking about. And so what we do is we acutely will manipulate exercise and nutrition and see how our muscles remodeling, right? And normally we are viewing remodeling through the lens of protein synthesis as opposed to breakdown, and could be a detailed conversation in itself. But what we see in healthy individuals, protein synthesis is the major variable dictating net protein balance. Okay. And if you want to build a bigger muscle or have even a higher metabolic quality of that muscle, we need routine periods of a positive net protein balance. Okay. So when I'm studying nutrition or exercise, I'm studying to see how protein synthesis is changing. And in healthy individuals, that's generally given us a good compass for whether or not we're in a positive net protein balance. So the more we can manipulate protein synthesis, the better net protein balance is. All right. So protein synthesis, another important thing to note is it's not a hypertrophic marker. Protein synthesis can be non-hypertrophic or hypertrophic in nature. So I don't know what it's going to translate into. Obviously, you'd have to run a training study to determine whether that stimulus that you're doing that just induced a large increase in protein synthesis is going to, in fact, build a bigger muscle. But what we can tell you is that you're either expanding that protein pool or you're renewing it, making it higher quality, right? So protein synthesis comes in various shapes and sizes. And protein synthesis is not a hypertrophic marker. I see that confused all the time. People always like to say protein synthesis equals growth. It never has, and it never will. It's a remodeling marker, and that comes in different forms. Okay, so that's sort of setting the backdrop of defining this maximal question. So if I'm trying to get a maximal output, my only objective is trying to increase protein synthesis as large as possible and not worrying about any other consequence or any other metabolic fate, right? So you can eat food protein in excess or maximally, get a large rise in protein synthesis, but it's going to be always coupled to a large rise in amino acid oxidation, okay? And generally, you're going to see that oxidative output go up when you're using isolated food proteins such as whey, any isolated food protein, because they're just too fast to get into circulation, right? So whenever you're using isolated protein powders, you're trying to choose or pursue a maximal response, okay? I'm always more interested in an optimal response. And so what an optimal response does, it's thoughtful about what is the other metabolic fate of the amino acids we just ingested. The goal with an optimal response is get a large rise in protein synthesis with a little rise in oxidation. So we're optimizing the food source, right? So it's easy to eat food protein in excess and get a large rise in protein synthesis, but you're also wasting a lot. Is there any problem to that? No.
When you say amino acid oxidation, are you, just to break this down for myself and the listener, are you saying that beyond what is being used within muscle protein synthesis, amino acids is it converted to glucose and then used to produce energy? Is that amino acid oxidation?
That can be one fate. There's, depending on the amino acid you're interested in, a lot of times in muscle physiology and protein nutrition, we study leucine oxidation, but with Luc Van Loon, who I worked for as a postdoc, just a prolific researcher and protein metabolism as well. So I've been fortunate enough not to only work with Stu Phillips, but also Luc Van Loon. Both are huge influences on my life. But when I was over with Luc, he would do a lot of phenylalanine hydroxylation. Okay. But a lot of times over here, and Stu as well, we normally look at leucine oxidation because it's primarily oxidized in your skeletal muscle. So what you're going to do is take those carbon skeletons out of that molecule, right? You got to get rid of that nitrogen, but you're going to take those carbon skeletons and make acetyl-CoA from it, and then acetyl-CoA is going to enter the Krebs cycle and follow the same metabolic fate as if you're making acetyl-CoA from fats or glucose. So depending on what amino acid you're looking at, I mean, you were referencing, alanine is a good gluconeogenic precursor, which will be turned into new glucose in your liver. So, but a lot of times, a lot of people in nutrition, we're interested in leucine oxidation, which is going to take place in your skeletal muscle. What other amino acids will be used in different ways. So it really depends on which amino acid you're viewing through. But oxidation, you can just sort of make it. You're not using it for protein accretion. You're using it for some other metabolic output.
And what's the problem with that? So you kind of alluded to the fact that the amount of amino acid oxidation, so the amount of amino acids that could go down this path of gluconeogenesis, be converted to glucose, or other pathways, so not being used for muscle protein synthesis, could differ between a kind of protein isolate, so having a whey protein shake or a pea protein shake, versus eating protein in food. What's the downside of having that, say, 30 or 40 grams of protein from a protein shake and having an increase in amino acid oxidation?
Yeah. So let me make this clear. There doesn't appear to be any detrimental impact on health as far as I can see. Meaning, if I'm routinely stimulating a lot of oxidation, it's not negative on your kidney. It's not in healthy individuals, negative on bone health. So the only thing I think the problem is that when you're routinely stimulating these oxidative pathways, you're creating a less efficient system. And this is some work from Dan Moore up in Toronto, who uses a pretty cool amino acid technique to determine protein requirements. But what he's shown is these individuals that are chronically eating high protein, stimulating oxidative pathways, have created an inefficient system, meaning they burn more of the amino acids coming in, and thereby elevating their protein requirements, because your system has got used to having protein in excess. It's used to trying to eliminate all that extra nitrogen in the system, that you've upregulated this and you become less efficient. He's shown that can do upregulate proteolytic and oxidative pathways. But the other negative consequence of generally eating high protein is that you start to displace other nutrients. Like weightlifters are notorious for going big protein and sometimes not getting enough carbohydrates. And so the other aspect of that is your protein requirements are going to be elevated when you don't have a glycogen, fully repleted muscle glycogen. You're also going to elevate your protein requirements. So I guess the short end is a lot of these higher protein recommendations for weightlifters are probably due to the fact that they're created an inefficient system. Chronically eating high protein upregulates proteolytic systems, can displace other nutrients, and also Luc Van Loon has some nice data showing that you also get higher splanchnic extraction rates, meaning your gut steals more of those amino acids, just again because you're eating in excess. So normally, it takes about 2 weeks to adapt down. So it's not like you can't come back from once you go high protein. You got to stay high protein. You can certainly come back, but you're going to be inefficient for at least 2 weeks after trying to come back to a more sane amount, or a more normal amount, or a more optimal amount, if you want to use that word. But again, there's nothing wrong with eating maximally. It's fine. You're just not being very clever with your food protein is the only thing. There's better ways to eat.
Do we see in the literature, though, that at sort of 1.6 grams per kilogram, let's take the lower end of that range that's often quoted, 1.6 to 2.2, do we see that at that level compared to, say, 1.2 grams per kilogram, that outcomes like muscle protein synthesis and hypertrophy are significantly greater? Or is that comparison usually made between like 1.6 grams and 0.8 grams?
Okay, so this this is something we've been advocating for a long time as protein nutrition researchers. It's what needs to happen is a large-scale randomized clinically controlled trial to answer this question, right? That's going to take a lot of money and an organized effort to do that. So what we're leaning on now are certainly, like meta-analyses, okay, which, you know, your meta-analysis is only as good as the studies that go into it. Let's put it that way. And I would say it's probably improving now, but in the exercise field, you have exercise physiologists who are not registered dietitians trying to do dietary recalls. Okay. So the information going into these meta analyses are probably not ideal. All right. Because exercise physiologists are not trained to do that sort of work. That's why it requires a multidisciplinary team to do this. And that's why I work a lot with registered dietitians to make sure I'm collecting the best data. And the other thing is, a lot of times, studies going into these meta-analysis looked at protein intake at the beginning and at the end. They didn't pay attention to what's going on here, right? And so they're just not reliable. So some of the information going into this data is just the best we have. We can only make recommendations on what we have. So my point is, we can improve on that, but that would take a lot of money, a large scale coordinated effort. I don't know where I was going with that. What was the question?
I mean, I think you're raising some interesting points here, and kind of what I'm hearing from you is that you're suggesting if you're not efficient at using protein, then sure, you might require this 1.6 to 2.2 grams to get the best outcomes. But it is possible to become more efficient at utilizing amino acids such that your daily requirement is actually lower because less of that amino acid is being oxidized. More of it is being used for muscle protein synthesis. So my question to you is, if someone's listening and thinking, oh, okay, so I'm hearing kind of for the first time here that maybe I don't need to eat as much protein as I thought, how can they kind of optimize to make sure that they are utilizing more of the protein that they're consuming such that they can actually just consume less total protein?
I don't think 1.6. That's a maximizing number. And again, the reason there's nothing wrong with doing that. I want to make that clear. That's just to make things simple for people, which is really important when you got a hectic lifestyle. You're just eating excess, you're good, right? Now, if you want to be more thoughtful, and I wouldn't say more efficient, it's just normal eating patterns, right? It's not really becoming more efficient. It's just how our recommendations are designed, per se. So the things I would do if you're trying to optimize your protein intake, I do a lot of work trying to leverage food matrix effects, right, to make better use of our protein nutrition. We're finding right now, I think, a lipid-rich food matrix, so a protein-dense and lipid-rich food matrix, is very good for our muscles. We're trying to understand the mechanism behind why these lipids are helping to potentiate the use of dietary amino acids. It could just be as simply as that it's giving a more moderate profile, right? But I think there's something with these lipids and the mitochondria efficiency would be my guess.
Is there a certain type of lipid? Are we talking about saturated fats, short chain fatty acids, medium chain, long chain? Are we talking about monounsaturated, polyunsaturated?
Sure, I know what you're saying. Not sure. We got multiple studies going on now that's doing different lipid manipulations to sort of pinpoint that question. Okay, I don't have the answer. We've seen benefits from all sorts of fats. All right, I think I wish we could pin it on one thing because that would make life so much easier, right? If we could identify a fat that was particularly anabolic or particularly helpful for amino acids, then we could just simply fortify the foods with that fat, right? I think nature is too clever for us, right? I think it's I don't know. I don't have the answer to that. It's an interesting point. It's a good question. I think I need about another 2 years to get that a better handle on that question. Now, keep in mind, the other point I want to make is that food, if you ever look at the postprandial release from isolated protein powders versus food, and this is factored into this optimal question, optimal versus maximal. All right. So when you eat, I'll just use whey protein because it's so dominant, right? If you look at the amino acid profiles after you eat whey protein, um, it's fast, right? You see rates, time to peak amino acid concentrations at about 60 to 90 minutes. Then it clears out of your gut. It's back down to baseline by 3 hours, right? Super fast. Food is very different. It doesn't peak to 2 hours, and it's released for at least 5, 6, 7 hours during the postprandial period, right? So very different profiles is going to dictate how we utilize that food. Okay. Now it depends on what is your goal. You've been focused on weightlifters, so I think a weightlifter, if they have the ability to go home and eat a food first approach, and what I mean by that is focus their diet on a whole foods, that's the way to go. I don't think they need whey protein in their life, right? But keep in mind, I understand that travel schedules and things, it's convenient, but that's not a necessity. Now, I think endurance athletes are a little different.
Can I quickly just ask you one question before we get to the endurance athletes there? So is that recommendation of yours based on the fact that for hypertrophy, it would be better to have the protein kind of slowly absorbed into circulation versus that kind of rapid in and out that occurs with the protein isolation?
Yeah, I mean, it's so fast. I mean, it's this window, the only reason you could rationalize why eating whey protein is beneficial would be based on the notion that there's a small window of anabolic potential that you need to get your food into circulation, right? A weightlifter doesn't really exist. So when the beauty of weightlifting is that it's fundamentally anabolic, causes a large rise in protein synthesis that's sustained throughout a prolonged recovery period. So anytime you eat during that post-exercise window, you're going to see that synergy between food and exercise, right? And so there's nothing magical about eating 1 hour after your bout. You can go home and eat a nice protein dense whole food meal and get just as much hypertrophy as you would if you were incorporating a lot of whey protein powders into your life. Now, sometimes when you're dealing with athletes, you need to overstress. If you take, it all depends who you're talking to. If you tell an athlete, okay, go home, eat some food, timing's not important, they might not eat protein and they just might not even worry about it, right? So sometimes as a practitioner, you kind of overstress the protein, like eat this right after your weightlifting bout because now they've consumed this protein in your hands and they're covered, right? As opposed to relying on them to go home. Most of us, though, are not top tier athletes. Most of us are just normal humans that are not trying to make money off of sport. So again, it's a different scenarios, but most of us have time to go home and eat a meal, and you do not gain any greater anabolic potential from inducing that whey protein or eating that whey protein immediately after that bout.
If someone is having a protein isolate, coming back to this kind of lipid effect that you mentioned before. So what I heard was that fats may be affecting amino acids and how they influence muscle protein synthesis. If you were having a protein shake, would it be helpful to add some form of fats to that?
No. This is an interesting question you bring up. So when I was over with Luke Van Loon, we had a big interest. So obviously, dairy's big everywhere, but particularly in the Netherlands. So we were sort of, I spent a lot of my postdoc trying to make casein more anabolic. It's a large proportion of milk protein, right? When you look at the ratio of whey to casein, the major milk protein fractions, it's 20%, 80%. All right. So I was tasked, or lab as part of a group, to try to make casein more anabolic. And so what we did was we added lipids to casein. All right. And what we found was simply adding dairy lipids to casein did not potentiate it. Okay. Did not make better use of those amino acids. That's why when we were running some of our whole food matrix questions here, was even more interesting, because that anabolic potential seemed to only stick provided we ate the protein within its natural lipid matrix. Okay, so if you deconstruct the matrix, you lose that anabolic potential. When you keep it intact within its normal matrix, that's where we see the greater anabolic potential. It's interesting. We've been running a lot of studies trying to understand what is so unique about this food matrix, right? And I'm viewing the food matrix through nutrient interactions. So food matrix effects can also be structural in nature. You can manipulate a food matrix by taking a piece of steak and mincing it up, right? So that would be manipulating the food matrix. So mincing up a piece of steak increases its digestibility. But what I'm talking about now is the food matrix from the perspective of nutrient interactions. And there's something with these lipids, and simply, as you alluded to, simply taking whey protein, adding fat, it doesn't appear to help it. You got to eat it within its intact matrix. I mean, it's cool. I mean, it's an interesting finding.
It kind of hints at this necessity for more studies to use whole food forms of protein in protein feeding, because much of the research is protein isolates, right?
Well, I mean, yes, I would say, yeah, 100%. I mean, all our studies, I think that paradigm is changing. You got to understand, the field is, you're going to start off anything from a very reductionist or a bottoms-up approach. So, some of the original work showed us that the essential amino acids are the major drivers of protein synthesis and net protein balance. And then, then you shifted to, start to do isolated foods, whey, soy, casein, right? So now we're up to probably to the food level. And then the next step is to do the meal combinations. And Luke Van Loon, all of us are starting to move in that direction. I sort of started this push with Luke, doing some meat versus milk comparisons. And then when I got to Illinois, I started to pursue this further. So you'll see a lot more of this coming out. But now, Simon, I want to allude to the fact, like, the problem, these food matrix effects are probably only relevant when you're eating more optimal or lower amounts of food protein. So if you're eating 30 grams of 30 grams of protein in a meal, you're sort of overriding the system. The food matrix effects are probably irrelevant. Food matrix effects are probably only relevant when you're eating closer to our recommendations, or closer to 15 to 20 grams of protein in a meal. So again, it comes down to, what is your goal, right? Are you trying to optimize or maximize?
Right. So if you're just getting protein everywhere you can, and it's up at 1.6 or 2.2, and a bunch of that's coming from protein isolate, it's not in the food matrix, it's probably going to be okay. But if you're someone that's getting 15 to 20 grams per meal, there could be a difference between person A, who's doing that from whole foods, and person B that's getting that from protein isolate. So I think that's super clear, and that's actually new information, I think, certainly for me and a lot of the listeners. I think people listening that maybe follow a ketogenic diet or a high-fat diet are probably quite pleased to hear what you were saying about lipids. But something that you said just before that was, if you don't have a lot of carbohydrate on board, you can have an increase in amino acid oxidation. So my question is, if someone's following a very high-fat diet that's very low in carbohydrates, do they have a greater requirement for total protein?
if you're eating low carbohydrates, it doesn't necessarily increase your oxidative potential. What it does is it increases your protein requirement. So yes, based on the work we have, people who are eating what you just said, high protein, low carb, are going to have higher protein requirements versus somebody who's eating closer to our, mixed meal recommendations. Okay, so that's a fair assessment based on the evidence we have. Absolutely.
Why is it that the body will convert amino acids to use to produce glucose, which then can be used to produce ATP? I'm just thinking here from like a survival perspective. It seems that I guess muscle tissue is very expensive. That's one thing that I hadn't thought about there, but it would seem counterintuitive in some ways to survival, and it would seem that if there was not enough glucose around, it would be better to use fat, stored fat to produce energy and spare protein, which is hard to build. Um, can you kind of explain, I guess, what the priority is there and how the body, decides whether if there's not enough glucose around, whether to use amino acids or use fat for energy production?
Yeah, I mean, yeah. At the end of the day, I mean, you sort of said. I mean, your central nervous system needs glucose, so you're going to do whatever it takes to provide it, right? Um, your muscle protein is that's your storage reservoir of amino acids, right? So during times of stress, you're going to particularly break down your myofibrillar proteins or your contractile proteins. So they make up about 60% of your total muscle mass or total protein mass in your muscles. So that's the prime storage site. Right? And that's a lot of times when we're chasing protein requirements, we're looking at the reservoir. So if we can hit the endpoints of the storage depot, then we're pretty sure we've satisfied total body uh, demand. Now, so you're asking me, why do you start to break down muscle as opposed to fat? Well, you're going to break down your muscle to also provide amino acids to those tissues because they still need to remodel, right? So it's not only glucose you're building. If you're in a survival situation, your muscle's going to get chewed on. That's just then you need that substrate to protect those vital tissues. Yeah, you'll make glucose, but you're also going to use that substrate to help sustain the mass of your other vital tissues as well. And you're going to see your myofibrillar proteins go. It's just the biggest reservoir we have, right? That's why I always wonder why people are interested in, this is getting off topic, but collagen, eating collagen to stimulate collagen protein. It just it just doesn't make a lot. That's not a reservoir for substrate, so it's not going to be as nutritionally responsive as some of these other muscle proteins. Just because it's not a large reservoir, why would you want to compromise your force transfer proteins to use those as a storage reservoir? So, I mean, your muscle is just the prime catabolic site. I mean, that's the reservoir of substrate.
Is that why some people say if you're in a calorie deficit, so you're expending more energy on a daily basis than you're consuming, that you should, in that context, actually increase your protein intake, perhaps even higher?
Yeah, no, exactly. So energy restriction is completely different. So that would change that optimal versus maximal paradigm we were just talking about. I mean, the most protective thing during energy restriction, obviously, is actually Stu has some cool work showing that I didn't think you could actually build muscle during energy restriction, but he's shown some hypertrophic potential, provided you're doing the right things during energy restriction. But you need to do exercise, in particular resistance exercise, and eat higher protein um, to help um, protect your muscle during periods of energy restriction. But it also depends on how much you're restricting. If you restrict too much, those two saving graces can't help you. I mean, if you restrict too much, even protein and exercise is not going to help you. So you got to be a little thoughtful about your restriction. And but certainly, if you're going to restrict, you need to eat higher protein and do some resistance exercise to help protect that your skeletal muscle. And I mean, I'm sure Don might have talked about this. Certainly, Stu would have. Skeletal. So, you know, Stu's the world leader on this aspect. So I'm sort of just saying what I've learned from him. But he's a huge advocate of high quality weight loss. If you remember that conversation, so weight loss is easy. High quality weight loss, you got to be a little more thoughtful. And high quality weight loss is trying to maximize fat mass loss by preserving as much muscle as you can. Okay, and that's the reason for that is that the amount and quality of skeletal muscle you have is the biggest contributor to basal metabolic rate, which for most of us is going to dictate total daily energy expenditure. So if we can protect our muscle, we're going to protect BMR or basal metabolic rate, and thus we can protect weight regain, right? The issue is if you're restricting and not being clever, trying to focus on high quality weight loss, you're going to lose skeletal muscle, and then it's just that cycle, right? BMR lowers, your total daily energy expenditure goes up, and then if you decide to refeed, you're going to set yourself up to weight regain. And so that paradigm is very different than a well-fed situation.
It's also such a big site for glucose disposal, so you're, I guess, protecting metabolic health at the same time. This episode is proudly brought to you by Inside Tracker. Track your blood biomarkers, understand your biological age, and receive personalized lifestyle tips backed by evidence to optimize your health. To get started with Inside Tracker today and get 20% off your first purchase, head to insidetracker.com/Simon. That's insidetracker.com/Simon for 20% off. So if we could just go back to earlier, you were talking about the bodybuilder or the person who was looking to grow muscle. We were talking about maximal versus optimal. You said, optimal would be more of a whole food approach as opposed to protein isolates, which are, entering the blood very rapidly and then going down. You were about to talk to endurance athletes. Is it the same for an endurance athlete who has slightly different goals to the person that's in the gym trying to build muscle?
Yeah. So sometimes, I guess you were talking about opinions and what I'm known for. When I'm I'm a huge advocate for food first approaches. And that's, trying to incorporate, whole foods as much as possible into an anabolic eating regimen. But that doesn't mean food only. Okay. Food first, but sometimes supplements are just necessary. And endurance athletes are different type of exercise, of course, but metabolically, it's also different. So when we run or ride a bike, depending on the duration and intensity, most people would view protein oxidation as quite trivial, right? That's, you're constantly thinking about carbohydrate oxidation and lipid oxidation. And that's sort of the notion. This is sort of what Don has advocated for. He's always like, you can say you have a protein requirement, but really you have an amino acid requirement. Okay. So that's very true when you're thinking about exercise metabolism or exercise amino acid metabolism. So if you view protein on a whole, not very interesting, but if you zoom in to certain amino acids, it's a little more exciting. Okay. You've talked about alanine. So with increasing exercise intensity, you're going to get increased release of alanine from the muscle. It's a good gluconeogenic precursor. You're also going to see a large increase in leucine oxidation. Okay. And so when you're running, you're oxidizing leucine, and, just put this in perspective. Let's say you go for a 60-minute run or a 1-hour run at about 70% of your VO2 peak, which most of us, a decent person could do. I probably couldn't. I haven't ran for a while, but most individuals can hold about 65 to 70% of their VO2 peak. Okay. So during that little hour run, you probably burnt anywhere between 2 to 3 grams of leucine. Okay. So what do you do after the bout? You eat protein. And to put that in perspective, I guess, how much leucine is in about 20 grams of whey protein? About 3 grams of leucine. All right. So guess what you need to do? So when you eat protein, you eat it, you have to replace that leucine amino acid oxidative loss, right? That's a necessity. But you also need to give enough substrate to help your muscles remodel. So endurance athletes are sort of fighting two battles. They're fighting the fact I need food substrate or amino acid substrate to help recover that leucine, and I also need to provide enough to make sure we're getting optimal remodeling. So the problem is they also need to make sure they're eating enough carbohydrate, right? Protein's important, but so is carbohydrate because they need to make sure, the glycogen's there taking the gas. And so stuff I've been working on with Dan Moore, again, an individual up in Toronto, a good friend of mine, also a great, very clever protein nutrition researcher, just like Stu. Um, we've been trying to understand how to re-optimize or recover leucine net balance during recovery from endurance exercise. So this is where I think an isolated protein powder might be particularly important. So you got an endurance athlete who can eat a whey carbohydrate blend, isolated blend, facilitate that rapid release, get that leucine into the circulation in a rapid manner, help recover that amino acid oxidative loss, and then, you know, transition to that food first approach where, they eat a proper mixed meal, right? So a great example where, yeah, it is a food first approach, but doesn't mean food only. And here's a situation where I think whey isolated food, it could be a plant based food source too, where I think these isolated food sources could be more useful for an athlete is in those, particularly for an endurance athlete.
Is the damage, you kind of defined that earlier, uh, from endurance exercise, I'm going to assume at a muscle fiber level looks different to the damage that we see from resistance training. Is that damage different? And is the total protein requirement likely the same for someone who is doing mostly resistance training versus someone who is doing a lot of endurance training?
It's elevated. Endurance athletes have elevated compared to their weightlifting counterparts because of the notion I just discussed. So again, this comes back to this notion that pro- protein synthesis remodeling comes in various shapes and forms, right? So an endurance athlete is interested in maximizing or optimizing, whatever word you want, depending on what you're doing, are interested in optimizing muscle protein synthesis during recovery from that endurance bout, right? Because what are they interested in doing? They need to build new capillaries. They need to build new muscle glucose transporters, new fat transporters. They need to remodel those myosin heavy chains to be more fatigue resistant, right? So they're synthesizing proteins, but it's going to be probably more non-hypertrophic remodeling, all right, which is very different than a weightlifter who's trying to focus on hypertrophic remodeling. They're interested in expanding that myofibrillar pool, right? Where an endurance athlete still wants to optimize protein synthesis, but they're pursuing it through a different lens. And what we found, and Dan Moore and I ran a study probably in 2017. Actually, I was talking to somebody about this. I was like, oh, this study never got a lot of action for some reason, despite it telling us so much. But we literally gave an endurance athlete protein recommendations that would be fine for a weightlifter, but we couldn't recover net leucine balance, and we couldn't optimize the remodeling response from a protein synthetic side because we didn't give them enough. And so that's when we were really starting to think, well, we can't just give a big bolus of protein to an endurance athlete right after the bout. So we probably got to be more clever with how we prescribe protein. Again, use that isolated protein carbohydrate mixture, then transition. So more frequent feeding for them to help recover. Very different than a weightlifter. So I said weightlifting is fundamentally anabolic. I mean, this is crazy why the weightlifters are chasing food protein. When you think about weightlifting, what happens? Your muscle turns into a bigger amino acid sink, right? Become more sensitive to your nutrition. A trained individual has better, in the fasting state, has better nitrogen retention, meaning they're better able to use the amino acids from breakdown. All right. And then what do weightlifters do? They instead of taking advantage of that fundamental anabolic situation, they eat a bunch of food protein and offset all that benefit. I'm not sure why. I think it's just that old school notion that I damage my muscles. I need more food protein to help them repair. More is better. I mean, it's just I always get we'll talk, and then what's the problem? Why do people intrinsically think they need so much food protein in their lives? And it's a great question. I think it's education. I mean, this is one reason why I'm talking to you, Simon, is that um, it's just trying to swim through the chaos of, social media or what have you. I think as scientists, we're doing a poor job of translating or perhaps not providing full context to what we're saying, right? Like I said, yeah, the 1.6, that's a maximal number. That's fine. There's nothing wrong with that, but it is maximal. So I'm a big thing, give the consumer the information and let them decide how they want to eat their food protein.
I think the approach of many bodybuilders is like a precautionary approach. If consuming a little bit more is not going to be harmful, I should err on the side of caution, and then I at least know I'm getting as much protein as my skeletal muscle requires.
Well, bodybuilders are a little different. They got a whole set of different rules they play by. I guess I'm talking to the general population, right? Physique athletes, bodybuilders, they need to manipulate their diet. Um, Food protein is satiating. When you're in an energy deficit, you want to take advantage of the satiating impact. Bodybuilders trying to eliminate carbohydrates out of their diet so they can, you know, tighten up their muscles. So very, very different than the population I chase, right? I'm speaking to, I'm advocating for the general population, not these niche areas. And again, athletes, bodybuilders, physique athletes, they need special consideration, right? I mean, everybody does, but it's a little different than, I guess, the information I'm trying to convey to you right here, Simon, is more aimed at most of the population, certainly not aimed at the bodybuilding community or athlete community, with the exception of the endurance.
If we think about the let's say recreational endurance athlete, someone that's doing, maybe they're doing 90 minutes or a couple hours of cardiovascular training a day, so they're clocking up like somewhere between 10 and 20 hours a week. Is the optimal protein intake for that person going to be around 1.6 grams per kilogram, or will it look different to that?
Yeah, so it's probably closer to that. So I don't think a weightlifter needs that much food protein. I think an endurance athlete perhaps could, but it's all going to determine on, if you do a 2-hour run, you're getting more amino acid oxidation waste. You need to account for that in your post-exercise recovery meal, right? And then you could split that even further, and I'm not to get too deep in the weeds, males versus females, right? I mean, females are better fat burners compared to their male counterparts, with the exception of during the luteal phase of your menstrual cycle. During that phase, you're actually a better leucine burner as a female, right? So you could argue that during that phase, to completely recover that net balance, you might need a little extra food protein, right? And again, usually as a practitioner, we don't worry about that because there's not a lot of evidence there to support that notion. But in terms of differential nutritional recommendations based on your menstrual cycles, but the other end of the continuum, there hasn't been a lot of work done in that area, so it's sort of a question mark. I would argue that endurance athletes could afford to eat closer to that 1.6, but they usually, the interesting part is that when you look at an endurance athlete, they already have high energy availability, so their protein intakes are quite high. I guess my concern would be more about the timing of that protein intake, right? In particular, of what we just talked about, making sure that post-exercise meal is sufficient of protein, followed up with that food first approach to the next meal. But otherwise, if you would just view an endurance athlete, their total protein requirement is quite high because they have high energy intakes.
If we're thinking about optimal recovery, so someone finishes a 1 to 2 hour run, they have 30 grams of an isolated protein. Does the proximity of the whole food meal that they're having that maybe is providing another 30 grams of protein to that matter? Is it something they should be having together? Or if they have it, let's say an hour or 90 minutes later, that's okay. I know a lot of athletes are not that hungry as soon as they finish.
Now we're getting, I could speculate. I would say I don't know the answer. Let's put it like that. So the best we can do is have make a hypothesis. But if I was to design something like that, as from a research perspective, I would, to test that theory that I'm talking about, to recover net leucine balance as well as support protein synthesis and subsequent remodeling response. Um, I would give that isolated mixture right after the bout, and probably 2 to 3 hours later is when I would try to get them to eat again and then study to see what happens. But that's just from a practical standpoint, I think makes sense for the reason you just said. But that's pure speculation, Simon. I'm just shooting from the hip at this point.
But if you were to speculate based on all the research that's out there, that would be a better strategy than, let's say, just having 60 grams straight after you finish, which is whole food plus a shake.
I would do that. Yeah, I would say that's a better strategy. I don't know that, but I would think that's not a bad hypothesis.
You mentioned before that the kind of distribution or frequency of protein might be important, particularly for endurance athletes. And this gets me thinking about some recent research that I think it was Tromelin that compared 0 grams of protein, 25 and 100 grams of protein after resistance training. I think you've probably seen that paper. But for a long time, there has, I guess, been this idea, at least in fitness culture and on social media, that if you consume more than sort of 30 grams of protein at a meal, that the rest is kind of lost. And this probably brings us back to amino acid oxidation. But then this paper came out, and at least the lay or social media kind of narrative around that study was actually, no, you're not wasting protein above 25 grams. You can have 100 grams of protein in a meal, and that seems to result in greater muscle protein synthesis. What, have you looked at that paper, and what are your, I guess, main takeaways from it, if you have?
Yeah, that's a awesome study. Yeah, it's Luke out of Luke's lab. Yeah, I know Jorn quite well as well. I worked with him a little bit when I was over in the Netherlands. Awesome group, great study. I think you might have hit the nail on the head. Maybe the social media took what they were saying and probably manipulated it a little bit. All right, so before I left the Netherlands, Luke is just a fun guy, just an amazing scientist. We talked about doing that study because we had an interest before I left. We were going to do it with intrinsically labeled beef. And he was just calling it the barbecue study. Then, got busy. I left, whatever. So I was real excited to see that paper because it was sort of something Luke was thinking about many years ago. And then to see it finally hit, but they used milk protein concentrates, so sort of shifted off the beef concept. But okay, so Luke has, and I went to the Netherlands to use this technique. Are you familiar with intrinsically labeled food protein?
I've read a little bit about it.
Sure. So, yeah, I made eggs here. So essentially, you're fortifying the food with an amino acid tracer and now we can trace where our food protein is going, right? So we can provide estimates of digestion and absorption kinetics, and then we can actually determine how much of the food protein is incorporated into muscle. All right. So it's a very interesting question because what you just noted is that we always wondered, when do you plateau the absorption of your food protein? Right. So some of Luke's original work showed that, okay, when you eat 10 grams of food protein, roughly 50 to 60% of those amino acids become available. When you eat 20 grams, roughly 50 to 60%. So the relative amounts are all the same, right? Obviously, from an absolute perspective, it's going to be stepwise in nature. So his question with that, obviously, was when I eat 100 grams, in this case, of whey protein concentrate, does that same percentage stay the same? Okay. And what the cool part about that was, that's paper, when you eat 100 grams of food protein, roughly 60% still becomes available, right? So that means the other half are going somewhere else. And then what he showed was that you use a substantial amount of those amino acids that became in the circulation for muscle protein synthesis. So that's a very unique part. So he labels the food protein at a high enough level. So when you drink, in this case, drink the milk protein concentrate, you can directly trace what you ate into muscle. Okay, so that's amazing. I mean, that's such a cool technique. And so he can directly see that, okay, yeah, you are. So those amino acids get into circulation and then you use them. All right. So Luke's a physiologist, right? I mean, I struggle with, what's the translation of that? He was just interested in, hey, if I eat 100 grams of food protein, how much becomes available and can I use it? Now, the only downside of that is they look at phenylalanine hydroxylation. It's not, they take it as a proxy for amino acid oxidation, but the situation would have likely been very different if they would have actually took a direct marker like leucine oxidation. But that's not to take away from that study. It's just that phenylalanine hydroxylation is sort of challenging to say it's amino acid oxidation. So what's the translation of that? It's just a cool paper. I mean, it's not our recommendations. Luke was just showing like, hey, if you eat it, it can get there. And yeah, beautiful paper. I love that paper. It's exciting to see that one come out. Now I understand perhaps people are maybe take that data and say, hey, I can just slam a big bolus in the morning and call it a day, but that's probably not the best way to be eating your food protein. But it certainly gets there. And the cool part is post-exercise state, so you make better use of the food protein. Yeah, it's just an overall great paper, but it's more from a science perspective. I would be hard pressed to translate that into my life, I guess.
Yeah, as is often the case, a study can be amazing, but the interpretation by the general public can sometimes be hit or miss. And what I was kind of interested in when I was seeing various takes on this by people on social media was that people were saying, well, this sort of shows you can just have 100 grams of protein early in the day, and that'll be just as good as having 25 grams split over 4 meals. But that's not really what they tested.
No, it's just, like I said, the real cool part about, my take-home point was that the relative percent stays the same. That's phenomenal. That's amazing. Our intestinal cells have the ability to get that into circulation. Now the interesting is what's going on. Where's the other half going? That's the more interesting part to me. Is the gut microbiota utilizing that extra substrate differently? Where is that going? Right. There's still a large amount that's not accounted for. Half showed up. Where'd the other half go? That's the interesting question to me. That's the more interesting part. And I know that's what Luke's interested in as well. That's not how I interpreted it. That's not how I interpreted that data at all. And keep in mind, that's a high quality food protein. So most of us aren't walking around slamming 100 grams of milk protein in the morning, right? It's just not how we eat. We eat mixed meals.
Based on the, I guess, totality of evidence that's looked at frequency and distribution, are you of the view that is there an advantage to multiple protein feedings throughout the day in terms of optimizing the system and being more efficient at using amino acids and reducing amino acid oxidation?
I think if you eat maximal amounts of food protein, frequency becomes less relevant. I think so, but if you eat more close to our recommendations, especially if you're on a more vegan-based diet, I think frequency is probably more important than if you're eating animal-based food proteins. That's my hypothesis. We're testing that hypothesis right now. We're almost done with it. So we're testing rather vegan versus animal-based eating patterns against the backdrop of different protein distributions matter. All right. So I think if you're eating high quality food protein, and the important part of that study is we held them at 1.1 to 1.2, right? So at these lower amounts against the backdrop of weightlifting. So we're trying to maximize the use of the food protein. And we're doing, our vegan diet is properly designed with registered dietitians using complementary protein pairings. So maybe there's, we've been clever with how we're using that vegan food protein, trying to make the most out of it, use weightlifting and use complementary protein pairings. So maybe there'll be no difference, but that was my original hypothesis, that if you eat an animal-based meals, doesn't matter. If you eat maximal amounts, probably less important. But perhaps where it becomes more relevant is when the quality of the food protein coming in isn't isn't as high. But like I said, maybe we can neutralize that by using those complementary protein pairings, because you can turn those almost into more animal-like when you are clever with how you eat. And most of us are eating mixed plant proteins. We're not just sitting around eating soy or something.
Mm-hmm. When do you expect the results from that to be out?
This summer. Yeah, we're almost done. We're wrapping up now. Yeah. Yeah, so it's almost done. Yeah, it's a cool study. COVID, we would have had it done, but COVID was tough on some of our clinical trials, so it got slowed up a little bit when we had to deal with the pandemic. But we're going to start the analysis, this summer, and we should have some initial outputs soon.
Yeah, I've been interested in that. There's been a couple of trials, Hamilton Rochelle, and then I think it's Alistair Montaigne, not sure if that's how you pronounce it, that have looked at animal or omnivorous diets versus vegan diets and looked at hypertrophy and strength. But that's been at more of a maximal dose of protein. They're up at 1.6, 1.7. And as you say, maybe once you get up there, the difference in protein quality doesn't matter. I have been really interested in knowing what is the difference at a protein intake that more reflects the general population protein intake. That is probably more relevant to a lot of the listeners who aren't sort of prioritizing protein at every single meal.
Yeah. No, again, that's the benefit of food first approach. They take into account what are our current recommendations, right? So I have nothing against people who are going high, but I even seen studies go upwards to 3 to 4 grams per kg per day. It's like, why do we go that way? Why don't you try to define this way, closer to recommendations? I think would be really, really useful, and that's what we do. But it's hard, especially here in the Midwest, where we are protein hungry just by nature, right? So another important aspect of that study is I work a lot with, again, Luke taught me to be more holistic in my thinking, and also got a lot of psychological well-being uh, readouts going as well. So I'm kind of curious what happens when you take a meat eater and put them on a vegan diet, right? Maybe we're protecting their muscle, fine, but maybe some of their feelings of how psychological well-being outputs are impacted, or maybe not. Maybe they're improved. Who knows?
Oh, I think anytime if you force someone to do something that they don't like, you might get some
maybe they like it.
Results,
yeah.
right?
Yeah, some people don't mind it. It's very individualized, right? But the reason why that's important, because you got to think about what our recommendations are doing. They're advocating for, and again, I have no issue with incorporating plant-based foods into an eating regimen. That's where a lot of our food protein's coming from. But they're advocating to incorporate more plant foods into our dietary patterns. And again, I have nothing wrong with that. But we got to make sure, we also got to be thoughtful about what is the downstream impact of that, if any. Maybe there's improvement. Maybe there's, obviously it's going to be individualized. But again, that's the only reason I think we got to be. The physiology is important, but so is the psychological part of it as well. So just trying to be thoughtful about that.
Sure. I think a lot of listeners will be thinking, okay, as a muscle physiologist, someone who has an enormous amount of knowledge in this area, both through reading other people's studies, but conducting your own studies, how do you personally approach protein feeding? What does this look like in your own life?
Yeah, well, Simon, I have 2 kids at home, so I'm constantly just, preparing. My wife's a vegetarian, so she usually she makes the plates look a little prettier than I would, right? But I don't use any isolated food proteins. I'm thankful for my wife incorporating some nutrient density into my plate, meaning making sure that we got nice, colorful plates with the vegetables and the grains. Otherwise, I'd probably just eat some cottage cheese and call it a day. I'm one of these individuals who um, I'm not a big foodie. Let's put it that way. But I use food first approaches. I mean, I do exercise, weight lift, but I haven't used any supplemental form for quite some time, since when I was in high school, probably, or just a lot of it's financial. I mean, I could afford it now, but some of that stuff gets a little pricey. And I always say, for my students, if somebody's on a budget constraint, what I used to do in high school and college is just used, if I was interested in isolated food protein, I'd just use skim milk powder. Convenient, put it into a blender, shake it up, and away I would go, and probably taking advantage of some of those food matrix effects. So, because I was quite innovative in its time. Yeah, I mean, I eat closer to that 1.1 to 1.2 grams per kg per day normal eating pattern. I am thoughtful about distribution only because I need substrate or food in my life. I get headaches. I mean, that's probably psychological, but I need, you'll see me eating about 5 times a day, just small little meals, and usually thoughtful about making sure I'm incorporating some protein into each little meal. But I'm never eating more than 15 to 20 grams at a time, and that's not necessarily because I trying to eat more optimally. It's just how maybe I am just intrinsically trained that way now, but it's just how I prefer to eat, like I said.
You sort of alluded to the fact earlier that there might be some sex-based differences in muscle physiology and or protein metabolism. If you were, I guess speaking here to a woman, would their approach to protein consumption look different to you or I?
Well, so the interesting part is, so a healthy young individual or even middle-aged individual, we don't really see a lot of differences at the muscle level, right? I was sort of alluding to the fact that the whole body level, there might be some difference in leucine kinetics, okay, but we've never seen anything at the muscle level, all right? So, and again, for an endurance athlete, recovering whole body leucine balance might look a little different, but where we're seeing some differential regulation, and this is some recent work that we just published, was in postmenopausal um, females. So, as we age, there's some differential regulation going on at the level of the muscle, which is kind of interesting. What we showed was, so I sort of talked about the remodeling response and protein synthesis being an important driver of that remodeling. So, in absence of food intake, okay, so when we wake up in the morning, we're in a constant state of turnover, right? So we break down our muscle protein, and that breakdown's providing the stimulus for synthesis. Okay, so what we saw in postmenopausal females, before we fed them or before we exercised them, so a baseline, their baseline protein turnover was elevated. Okay, that's interesting because when we exercise or feed them, due to that elevation or that ceiling, they're not able to elicit a big response. Okay. So now we're at the initial stages of how do we fix that? So you'll see like nothing nowhere near, the postmenopausal females are nowhere near as extreme, but you see the same thing in hemodialysis patients where they have a high, so kidney disease patients, they have a high elevated baseline that when you try to exercise or feed them, the signals are just ineffective. Now, postmenopausal females are so it's much more mild than that situation. So some of the Danes have sort of yet to dive in the literature a little bit, but they're suggestive that estrogen replacement therapy is pretty beneficial. We're not trying. I'm not a pharmaceutical manipulation guy, so we're trying to be a little more clever with nutrition and exercise manipulations to see if we can sort of sneak those signals in there over top that elevated baseline. I mean, we already intrinsically know that older men need a little more volume than younger individuals to elicit a maximal resistance exercise response. All right. So whether or not that's true with postmenopausal females, maybe we can maybe we can make it more effective if we put a little more volume, usually by repetitions. I don't know. I mean, this is, like I said, we just published this work. I'm still reflecting on it, trying to make sense of it. But this was just recently published last month or maybe this month. I can't remember some of that work.
So outside of hormone replacement, in order to fix that, you're thinking that it's more likely an exercise thing, so increasing volume, as opposed to just increasing protein up to a much higher level?
Yeah, I think we need to hit them. I think we need some better exercise manipulations. I did in that particular study in these postmenopausal females, we just did a pretty standard at resistance, 3 sets of 10 of leg extension, right? Which is generally pretty effective in younger individuals. Um, I don't know. I gotta figure that out. It's real important that we figure that out. I don't, maybe volume, maybe there's something with the nutritional manipulation, trying to think how we can get a better push on the muscle. Is there something we can fortify a food with to help push it? Can we leverage these food matrix effects? I don't have the answer to that right now, Simon. I need a little more time to reflect on that. But we are seeing differences. I think that's an important area that we need to study, particularly at the aging. These sex-based differences at the aging level and at the muscle level, I think, is particularly important. And maybe it's that. Maybe it's just the hormonal replacement. I mean, with estrogen, I'm not sure. I mean, that seemed to work, but there's certainly more. Like I said, that's not my job to start prescribing pharmaceutical manipulations. I always try to use a nutrition and exercise manipulation first. So I'm going to need some time on that to see if I can get something in there for it to work. Yeah.
Let's finish here on supplements. And I think I already know the answer to this based on everything that we've discussed so far. But just to be super clear, what are your thoughts on supplementing essential amino acids or branch chain amino acids? Is there ever a context where you think that might be helpful?
Um. Yeah. So, I mean, in terms of the branch chain amino acids, my normal response is, why eat a couple amino acids when you can eat them all, right? I mean, it doesn't make a lot of sense to don't eat the full complement of amino acids. Obviously, you need those to build a functional protein. If you're eating, for instance, you can just feed leucine, you might get a little kickstart in the muscle, but you can't sustain the remodeling response because you deplete your intracellular free amino acid pool. All right. So I'd normally say if you're interested in eating branch chain amino acids, just eat a whey protein supplement, because that way, at least that supplement's already high in branch chains, and you're eating all the other amino acids as well to help support a more maximal response. In terms of, free form amino acids are interesting, right? So they're easy to manipulate, meaning you can formulate those mixtures, no problem. So, a lot of times when you're looking at an ideal amino acid composition of a protein source, you want it to mirror the amino acid composition of interest. So for a lot of us, what I just said was your skeletal muscle is the primary reservoir. So normally you want to eat amino acid. You want your food source to mirror the muscle protein, right? So, we have a lot of nice work showing here's your amino acid composition of skeletal muscle. So if I was a manufacturer making free amino acids, I would match it, right? So easy to do that with. The problem is, as I alluded to, they're too fast. They're just too fast. They absorb into circulation super fast. They come in and come out, right? So you're probably getting a good oxidative signal there with those fast releasing food sources. Now, Luc Van Loon has some work where he speculates that, free amino acid digestion is effective. I'm not saying it's not effective. It does work. But perhaps the utility would be in an aging population. We know aging has some issues with digestion and absorption. So perhaps, if you're an older adult who's having some satiety issues or compromise from a digestive health standpoint, maybe they have a role. But in a healthy individual, young to middle age, I just don't see their utility. And I certainly don't see the utility of branched chain amino acids. I've never really understood that, Simon. The whole concept never made sense to fortify your diet with free amino acids. I mean, a good example is, if you talk to the agriculture individuals, so largely they're interested in maximizing food production, right? So, here at the University of Illinois, we have a big animal science and trying to maximize our agricultural growth and food production. They generally will laugh if you tell them we're running around fortifying our diets with free amino acids, because they've known for years it's not that effective. And actually, in their models, they induce what you would call amino acid antagonisms, where, let's say, if you eat too much leucine, you could interfere with the absorption of isoleucine, and now you have a limited supply of amino acids, and now you've actually, in their models, impaired growth. Unlikely probably to happen in our human model, but still, it just doesn't make sense to spike in a lot of free amino acids into our diet. You could argue that in an old person who has an anabolic insensitivity, throw some leucine in there, that perhaps it can help kickstart their muscle. But I really don't see the utility in it for most individuals. Let's put it that way.
You mentioned collagen earlier, so perhaps we finish here. Collagen supplements have become very popular for skin, and also marketed for, I guess, recovery from connective tissue kind of damage, ligaments, tendons, that sort of thing. How do collagen supplements compare to whey or common plant protein blends if we're thinking about muscle and connective tissue?
Yeah, I mean, the college stuff was interesting, right? I mean, the idea there is, you can eat some chicken broth, eat some Jello or gelatin. The reason they were doing that is because, sort of going back to what I just used, that example of skeletal muscle and mirroring the amino acid composition. They were, for some reason, doing that from the perspective of, if I eat, I mean, the most simple way to think about it, and it makes no sense. If I eat collagen, I'm going to stimulate collagen protein synthesis, throw in a little vitamin C to help with the cross links, right? But again, you got to think about, collagen has never been that nutritionally. It's highly exercise responsive, but it's not really nutritional. I mean, beyond its normal remodeling, it's never been really sensitive to nutrition because it's not really a good storage reservoir. Why would you want to make that a liable pool? Because it's so vital to transferring that force out of our skeletal muscle, to the bone for subsequent movement. So the concept doesn't make sense. And also, in our normal eating pattern, proline, they're not rate limiting in our diets. So I've never really understood why they're recommending collagen supplements. I mean, I come back to your point. Just eat some whey protein if you're that concerned. At least it has a better amino acid composition relative to collagen. Yeah, the work I've seen in that area, I just don't see it doesn't work, and the science behind it doesn't make complete sense to me.
What do you mean by proline is not rate limiting?
I mean, look in our dietary pattern is proline, methionine. We're getting enough in our normal eating patterns. We don't need to be supplementing with these amino acids. I mean, that's what our guidelines are designed to do, is to meet our minimal requirement, right? And so the reason you would supplement is yeah, perhaps if you're not eating anything, you'd have, maybe it'd be beneficial, but a supplement is to be, it's just that you're supplementing an adjunct to your normal eating pattern. And somebody who's eating a well-fed diet, it would make zero sense to supplement your current diet with collagen protein. I mean, it makes no sense. And I just don't see the physiological rationale. I never have. And the data doesn't support it. I mean, I'm not sure if you've been watching or reading the data coming out, and it's always been shown ineffective. And my point is, usually when I'm reviewing that work, they paint the narrative of why. But I'm like, at this point, we know the narrative doesn't make sense. So why? I'm not sure why researchers who are doing that work still paint the narrative like it's effective, where we know, yeah, that might have been the rationale 10 years ago, but we know enough now that that narrative behind it doesn't make any scientific rationale. It doesn't have a scientific rationale, and it's fine if you run those studies, but just shape it as within the current knowledge. So I'm, yeah, based on what I've seen, certainly not an advocate for collagen for athletes. I mean, there's some stuff there I just don't even see it for the benefit for even if I'm injured. I mean, there's an idea there that so your collagen protein doesn't. So what you do is, right, like if you're a pitcher, you'd warm up your muscle a little bit to stimulate collagen protein synthesis, and then you'd eat some collagen to help with the repair and remodeling. But I don't know, Simon. I'm not convinced, and the scientific literature hasn't convinced me that's an effective approach. Yeah, I mean that's I guess my read on it at the time. I can be proven wrong. I'm not an advocate.
There's probably a bunch of people listening thinking, "Damn, I'm wasting some money." Well, at least it's an opportunity to perhaps save some money going forward.
Well, I mean, again, I'm not here to tell somebody who's right or wrong. I mean, it's if you enjoy incorporating that, and I don't know the taste of it. A lot of that is like whey protein powders. Some of it tastes pretty good, right? And if that makes your life a little more enjoyable, just like if collagen, the placebo effect is huge. If incorporating that into your eating regimen somehow makes you feel better, then you can afford it, then I'm not going to say be you. I'm not here to tell if somebody's right or wrong. My only point here is I don't see the scientific rationale behind it, and the evidence isn't there to support it. But again, that's just what science says, and science is we're a little slow sometimes, right? So it takes us a couple years to get the information out there. So perhaps there's something coming down the pipeline that could convince me otherwise.
I appreciate your focus is more on skeletal muscle and connective tissue, but as someone who understands, I guess, how proteins are digested and then absorbed, something, another claim that I've seen with collagen is that it can be broken down into these peptides, which are absorbed as peptides, not as amino acids, and the peptides end up in skin. There's a whole beauty industry that's built on this. So as someone who understands the physiology and how we digest and absorb protein, is that possible that consuming these collagen supplements does in fact increase these important peptides in our skin?
Well, anything's possible, Simon. I mean, the point is so cool. Some would argue, but they do transfer. So some would say you cannot transfer. Some of the original work was suggestive that these peptides weren't even making it into circulation, right? I mean, I've done some work with like dileucine or dipeptides and other peptides, and they do in fact transfer. So to your point, perhaps, yeah. I mean, perhaps they are helping your skin. I mean, I'm not big into that area, but the coolest part is, I would say you're correct. We actually see these peptides show up in circulation, which is actually crazy. And if you looked at this is even cooler. If you look at some of the Dutch research, I'm forgetting the lead author's name, but they have evidence to show that in the post-exercise state, you're getting better transfer of peptides, food-derived peptides, right? And that's probably because you got to remember, exercise is very damaging, right? So your gut's an athletic organ as well. So when you exercise, obviously what happens is you start to shift your blood flow to your working muscle. So you underperfuse your gut, and then in the post-exercise state, you get all that blood to rush back. and then you damage it. So when we think about gut damage, usually you look at it from gut permeability standpoint. So your gut's more permeable. And so what they think is that in the post-exercise state, you're getting better transfer of these food-derived peptides because of the greater permeability, which in turn goes back to to my passion, is that exercise and nutrition go hand in hand. You can't view them in a silo. I mean, the same things with protein quality, as well. Exercise is probably changing protein quality because it's based on digestibility. But I mean, that's so cool to me that, yeah, we can transfer these peptides, but you're also getting better transfer in the post-exercise state, which is crazy. I mean, it's so neat.
So what I took from that is that Nick Burd is recommending post-exercise collagen peptide supplementation for skin
For
health.
skin health, yeah.
That's the regime, the beauty protocol.
Yeah, I mean, yeah, that's fair assignment. Yeah, everybody quote me on that. I mean, I don't have the expertise in that area, but to your point, these peptides are transferring. I mean, again, I'm only thinking about it from a skeletal muscle perspective, so you're very true. What are the other impacts? You certainly need to think more holistically, and I'm not the individual to be talking about collagen peptides and their ability to potentiate skin health. I'm not the person to talk about that. So that's a very fair statement.
Nick, are there any, I guess, major protein myths that come to mind, things that you see in the media or social media that we haven't covered that you would like to clarify?
Oh, yeah, that's a good question. Actually, it's funny you mentioned this because we've been thinking about these. So at Nutrition 2024, which is in Chicago, it's American Society of Nutrition. We're organizing an event, a protein myth busting event at that conference. I think the title is related to trying to define or translating from bro science to pro science. Trying to, but we're actually asking people what myths do they want us to bust at this protein myth busting event. And Stu Phillips will be there, Dan Moore, myself, and Nancy Rodriguez, amongst a couple others. So I think I'm not connected enough to understand what are the myths. So, I think you hit it: the branched chain amino acid supplementation. Optimal versus maximal, how much can you absorb? I mean, that's the big one I hear all the time. And I think Luke did a beautiful job in his paper, Jorn being the lead author there, showing, hey, you can eat 100 grams of food protein and roughly still half becomes available, and you can use it for protein accretion. Like I said, the question is, where does the other half go? I have no idea, but it's still that's still cool. I mean, I don't. I mean, Simon, you'd have your finger on the pulse better than myself. What are some protein myths? And I think the big point is I'm just a huge advocate of these food first approach. Be more clever with your food protein, but you can eat all the food protein you want, but the biggest life variable we can all do is exercise, that, and be consistent with it. And then, I always say exercise is the major stimulus. Then we use nutrition to try to squeeze a little more out of that exercise stimulus. And again, I view them as they go hand in hand together. I said, be consistent with what you're doing, in particular from an exercise approach. But I'm an exercise physiologist, so I'm always going to advocate for exercise.
And just to finish here, you've spoken to a few things, but are there any kind of other significant things related to protein or protein metabolism that come to mind that you've changed your mind on over the years as new research has come out?
Yeah, I mean, it's been those food matrix effects. I mean, my original assumption was, we've known for some time that, this is sort of the line of thinking that the essential amino acids are the major drivers. Adding extra energy to those essential amino acids are not particularly anabolic, right? What we're seeing now, and this has sort of really changed my line of thinking, is what I just alluded to. Our work has suggested that these food matrix effects are real. The potentiating the use of amino acids when we're eating closer to our recommendations. They're probably not as important when you're eating more maximally. And I need to understand. I think my next big push is, I think there's something with these lipid-rich food matrix. What is it about how this protein and lipids are interacting within that food matrix that is potentiating their use, right? If you deconstruct the matrix, you lose that anabolic potential. I mean, to me, that's crazy. I mean, I'm trying to understand that. And, is there a relationship to the mitochondria? Is there, what are these lipids doing? That's fascinating to me. That's why I think food is so, isolated protein is just that. It's not that exciting to me because it's just that. It's just protein, right? You got some leucine to help with the anabolic trigger, but otherwise not that exciting. The food matrix is real exciting to me, and how are different components of the foods transferring? How does exercise impact this? I think these are real exciting areas as a scientist to try to understand. I mean that's where my mind is now. I think is trying to define that, chasing that question. That's what I always say, you found success when you wake up in the morning with a smile on your face. And then, every day, Simon, I come to work with a smile on my face, surrounded by a great team of graduate students that we have a lot of fun. If you're not having fun, what's the point? And these questions make it fun. My team makes it fun. So, we'll see. We'll see what we can get into within the next 5-10 years.
Yeah, I'm excited to see what you come up with, and hopefully you can come back and share with us. I'm also interested in that vegan versus omnivore diet kind of optimal intake study.
I often reflect on, man, what question do I want to answer? And that's one I actually wanted to, sometimes, just depending on, what's going on, all science questions are exciting. Yeah, you're right, Simon. That's the one that's what makes me smile every morning. I'm like, that's going to be a fun one to write about and to see. I'm excited for that one. Yeah, let's put it that way. I'm excited for that one.
Please come back. You're welcome anytime. Come back and share the results with us. Nick, this has been really, really interesting. Thank you so much for all of your work, joining us today, appeasing my curiosity. I've thoroughly enjoyed it, and I'm sure it will be particularly helpful to the listeners.
Yeah, we talked. Like I said, it's just one perspective. It's science is all we can do is I always just be thoughtful about it, think about it. Does it make sense? And and that's all I'm trying to do. I don't have all the answers. I'm not trying to change it. It's tell anybody they're right or wrong. I'm just hoping, I'm trying to provide some information just to help people think about, just be a little more thoughtful. I think that's the major goal. But I'm happy to help, Simon. Thanks for the invite. It's been fun.
You're welcome. Thank you so much for joining us. There you have it, friends. I hope you enjoyed this episode. If you did and want to stay up to date with future episodes, be sure to hit that subscribe button on YouTube and follow on Apple or Spotify. Finally, thank you for showing up and the effort that you're making to take control of your health. I look forward to hanging out with you again in the next episode.